Hello everyone and welcome back to Diksha Karnataka YouTube channel. So we have already completed question number 1 till question number 30 for KCET 2024 paper. So we are currently discussing KCET 2024 physics paper, and today I am going to discuss from question number 31 till question number 60 all the questions that came in 2024 paper, and we will also mention which questions are deleted, which questions maybe is a bonus question. So we are going to discuss everything. So if you have not seen our question number 1 to question number 30 yet, don't forget to watch that video. The description will be given in the pinned comment below, so don't miss out on that. Now let's start with our journey for the question number 31. So the total electrostatic flux through a closed spherical surface of radius r enclosing an electric dipole of dipole moment 2aq is given by. So remember that a dipole basically means 1 plus and 1 minus charge, right? So 1 plus and 1 minus charge is enclosed inside a spherical surface, okay? So what is the total charge enclosed? What is the total charge enclosed in this case? So Q total should be equals to plus Q minus Q, that is 0. So whenever a dipole is enclosed, total charge enclosed is 0. That means there will be no net flux through the surface. So no net flux through the surface, that is the answer for this question. Now, under electrostatic condition of a charged conductor, which among the following statement is true? So this type of question is very common in KCET. I am going to discuss what strategy you should follow while answering this type of questions. First, you have to check each and every statement and cross them if they are incorrect, okay? So if there are no other strategy, you have to check each and every statement and cross them if you think they are incorrect. Maybe sometimes you may be confused between two given options, but you have to clear in your mind this is incorrect or this is correct, okay? First, the electric field of the surface of a charged conductor is sigma by 2 epsilon naught, where sigma is the surface charge density. This is not correct because we know that it is only because for a charge sheet. When the charge sheet is there, only in that case for an infinitely long charge sheet, that is the electric field is this, right? So this answer is not correct, okay? For any conductor this is not correct, right? Because they have generalized it for a surface of charged conductor. So you have to remember that though it is electric field due to a charge sheet, this is not a generalized statement. You cannot generalize it for any charged surface. So there are few conditions. It has to be charge sheet, it has to be infinitely long, then only this statement is correct. The electric potential inside a charged conductor is always 0. Now this is a very confusing statement for you, maybe because you know that electric field inside a charged conductor is 0, not potential. Potential is always constant. So this is also a wrong statement. But this might confuse you because you might think, okay, this is a correct statement because electric field is 0. So electric potential, instead of reading electric potential in your mind, it will say electric field. So be careful of this kind of distractions. This is actually electric potential. Electric potential is not 0. Any excess charge resides on the surface of the conductor. As I already discussed that if you give any charge to a conductor, the charges will always float to the surface, okay, as if they are floating on water. So this is a statement. So this is a correct statement. So we know that this is a correct statement. Now let's check the option D as well. The net electric field tangential to the surface of the conductor, this is also incorrect. Electric field is not tangential to the conductor. So for example, let's suppose this is a spherical conductor, okay. So in that case, electric field is outward. Electric field is outward and it is not always tangential. Tangential means if it is along this direction, then we say this is tangential, but it is not tangential, it is perpendicular, right? So that's why this is also an incorrect statement. Only correct statement is this. So this three statements are incorrect, only this statement is correct. So after reviewing all the option, you have to review them quickly so that you don't miss out on time. A cube of side 1 centimeter. So the side 1 centimeter of the cube contains 100 molecules. So number of molecule is 100. Okay. Having an induced dipole moment of, so dipole moment of, so first write down all the variables given in the question so that you can use that, okay. in an external electric field of 4 Newton per coulomb. Okay. So the electric susceptibility of the material is, so now you have to calculate the electric susceptibility of the material. So for that we know that number of molecule is 100, each molecule having dipole moment P. So polarization of the medium, there is a formula given in polarization. Polarization per medium is given by number of molecules times the electric dipole moment of each molecule divided by its volume, that is called the polarization of the medium. So polarization is capital P and this is small p. So what is N? N is 100, P is 0.2 times 10 to the power of minus 6 divided by volume is 1 centimeter. So always I say from 1 centimeter, if you convert into meter, it will become minus 2 meter. So you have to multiply with 10 to the power minus 2. Here it is only 1 centimeter, so it directly become 10 to the power minus 2. Now for a cube, what is the volume? Volume is a cube, right? So volume for a cube is sides cube, that is 10 to the power of minus 2 whole cube. Okay. And if you calculate the unit coulomb per meter divided by meter cube, that will be, so the final unit will be coulomb meter to the power minus 2. Okay. Now if you calculate 10 to the power minus 6 here, 100 times 0.2 is 20. So let me just clear this little bit. So 100 times 0.2 is 20 times 10 to the power of minus 6. In the denominator 10 to the power minus 2 whole cube, that is another 10 to the power of minus 6. They all cancel. It will be 20 coulomb per meter square. Okay. So this is the polarization of the medium. Now to calculate the susceptibility, what formula you have to use? There is a formula given in your book where it is given by P by epsilon naught E. Now remember that in this case, when you are calculating like this, susceptibility is unitless quantity, but here a unit is given. Okay. So when the unit is given, you should know that there will be no epsilon naught. Okay. There will be no epsilon naught when there is a unit given. Okay. This is a special trick that you need to know. Now polarization is 20, electric field is 4, so it will be 5, and unit will be coulomb meter cube, and there will be 1 Newton per coulomb. So coulomb square will come, and you will get coulomb square Newton inverse per m to the power minus 2. So this is the answer given. Okay, 5. So what is the correct option then? Correct option is option B. Okay. Now move on to question number 34. A capacitor of capacitance 5 microfarad is charged by a battery of EMF 10 volt. At an instant of time, the potential difference across the capacitor is 4 volt, and at that time the rate of change of potential. So what is all the options given? Capacitance is 5 microfarad. Okay. By the battery of EMF, the EMF of the battery is given. Let me write it capitally, even though we are not going to use this value in this problem. At an instant of time, the potential difference of the capacitor at an instant, some instant, V is given 4 volt. Okay. And the rate of change of potential difference, the rate at which the potential is increasing, rate of change of potential difference, it is given as 0.6 volt per second. Okay. Then the time rate at which the energy is stored in the capacitor at that instant. So time rate of energy they have asked you. You know that energy is given by half CV square, right? Energy is given by half CV square. So what we can do, if we differentiate both sides, with time du by dt, then we can find this as half. Now C is constant. Okay, half is obviously constant, C is constant, then what differentiation will happen? Only V is differentiation. V's differentiation is x square differentiation, 2x dx by dt, right? So here it will be 2V dV by dt, right? Now at this instant they have asked you to find the time rate of change of energy. Time rate of change of energy is du by dt. So a slight information about rate of change. What is the meaning of rate of change? If you know that the differentiation is means rate of change, then you will be helpful. It will be helpful for you. Now C is given 5 microfarad. C is given 5 microfarad. Okay, 2 volt at this instant. At this instant, they have given you the potential as well. They have given the potential as well. At this instant, potential is 4. Do not use this value. This value is total potential, maximum potential. Okay, when the battery, when the capacitor is fully charged. At this instant, the voltage is 4, and rate of change of potential is 0.6. So dV by dt is 0.6. So if you put all the values, you can calculate these values. 2 cancels. Okay, 5 4s are 20. 20 times 0.6, it will come out to be 12, and the capacitor was microfarad, so it will be 12 micro joules, microwatt, sorry, because joules per second, there is a rate of change, right? So rate of change means joules per second, that is watt. So 12 microwatt, that is option A is correct. Okay, because V is dV by dt is given as volt per second, right? So volt per second means the final answer will be joules per second. That's so joules per second is watt. Now, electric field inside a conductor. E is the electric field inside a conductor whose material has a conductivity sigma and resistivity rho. The current density inside the conductor is J, the correct form of Ohm's law. So we know that J, current density J in vector form is equal to sigma E, right? It is given in your books. This formula is given, but if you see these options, none of the options are given. This is the form of Ohm's law. So this option is not given in any of the formula. Okay, so J is given as rho E. So this is not correct, right? So don't get fooled and mark this option. No, this is not correct. J is sigma E. Now conductivity is inverse of resistivity, right? So conductivity is inverse of resistivity. If you know that, then you can answer this. So you have to put this value here. So 1 by rho into E. Now let's find E. E is rho into J. Okay. So E equals to rho into J. That is option C is correct. So this is very simple, right? This is very, very, very simple. So if you just know this one 2-line theory, you can answer this question. So if you have studied for 1 whole year, this question would have been very easy. Now this is a very interesting question. In the circuit shown below, in this circuit shown below, the potential is V naught. This potential, this is grounded. Okay, the electric current I indicated in the circuit. So electric current I indicated in the circuit. What is the electric current I in this circuit? So here I have they have indicated I. Whatever current is going through, the total current is I. Now you have to find the current I. So see, they are all a jumbled circuit, but if I current is in the middle, the same current should go in and same current should go out as well. Okay, so same current should go in and same current should go out as well. Now what you have to do? So you have to do one thing is you have to simplify this circuit. So you know that, I hope you have done this kind of problem. This is a very common problem. If there is a circuit like this, you have to remember that this circuit is nothing but a modified Wheatstone bridge. Modified Wheatstone bridge. We know Wheatstone bridge looks like this. Wheatstone bridge looks like this. Right? and in most cases instead of this there is a galvanometer given here. But that galvanometer has some internal resistance, so in general we represent this as resistance as well. Now we know that the condition for balanced Wheatstone bridge means when there is no current flows through this galvanometer. Galvanometer can be considered open. If there is no current passing through it, you can simply remove it, right? You can simply remove it if no current is passing through it, right? So now it becomes two parallel resistors. This is the trick that you have to learn, you have to know. Now what is the condition? If this is P, this is Q, this is R, this is S, then P by Q should be equals to R by S. If this condition is met, then we can safely remove the galvanometer because there is no current passing through it, and in that case we can simply consider P and R in series, Q and S in series, and then this combination is in parallel with this combination, right? Now let us check which one is the galvanometer resistance in this case. So whatever is the center of everything, here this and here this, where these two junctions are met, these two junctions are there, these two are considered as the combination. So these two junctions, between these two junctions, whatever resistance is here, between these two junctions, whatever resistance is here, that is called, sorry, not this one, between two junctions, right? This junction is coming from here. Between these two junctions, whatever resistance is here, so that too is, so first consider this one. First consider the first circuit, okay? In the first circuit, you see this is the part which you have to consider for galvanometer resistance. So you can see that all the resistances are R. So R by R obviously equals to R by R. That means this is not connected to the circuit. You can easily ignore this. Similarly, if you see 2R by R, 2R by 2R, this is also 2R by 2R. So this is also 1, 1. So this is also not connected. You can simply scratch these two resistors because they are in Wheatstone bridge balanced condition. So you do not need to consider about these two resistors. And most of the cases, whenever you see this kind of circuit, okay, when resistance is connected like this, and for KCET examination, you should know that this central resistance will mostly there will be no current flowing through these resistors. Now, what I said that these two are in series. So these two are in series. That means the resistance of these two in series is 2R, and these two are in series. So resistance of these two is also 2R. Now these two things are in parallel. They are individually in parallel. Sorry, my mistake. This resistance and this resistance are in series, and this resistance and this resistance are in series. So they are in series, okay, and then entire combination is in parallel, okay. So these one and see, this is connected like this. So these two are in series, 1 and 2, and again 3 and 4 are also in series. Now 3 and 4 are also in series. Right. So what we have to do, we have to just find R plus R is 2R, and another R plus R is 2R. So they are in parallel. So what is the equivalent resistance of two 2Rs connected in parallel? So simply we will write, say this resistance is R1 will be equals to 2R into 2R by 2R plus 2R, it will be R. Okay. Remember this, when two equal resistances are in parallel, then their equivalent resistance is half of any of them. Okay. So if X and X, two resistances are in parallel, their equivalent resistance is X by 2. Just remember this, this will come handy when you are solving some complicated question. Now similarly, in this case, if you see, these two are and these two are in series, and these two are and these two are in series. So what is the total resistance? 4R here, this is also 4R, right. So now what is the equivalent resistance? I already told you the formula. So R2 will be 4R by 2, that is 2R. Now these two resistances are in series. These two resistances are in series. So what is the total final resistance? Final resistance is R plus 2R, that is 3R. Right? Now voltage is V naught. Voltage across this is V naught. So we can simplify this as a resistance of 3R is connected with a battery of V naught. Right? This can be simplified as this. This is the equivalent circuit of this entire thing. So what is the current in the circuit? The current in the circuit is I is equal to V naught by 3R. Right? So V naught by 3R is this value. So this one is the correct option. Okay. If you have practiced this, you can solve it in less than 1 minute. I can solve it in 20 seconds. Maybe you can solve it in 30 seconds if you practice it. Okay. I just see this circuit. I say, okay, this is the equivalent resistance R. This is equivalent resistance 2R. Total resistance is 3R. Then V naught by 3R is the current. Right. Now, let's move on. The electric current flowing through a given conductor varies with the time as shown in the graph below. The number of free electrons which flow through the given cross section of the conductor at time 0 less than t less than 20 seconds. So basically the circuit is given and they have asked you to find the total number of charges flowing through this till this point. Okay. So now you remember that current is given by Q by T, right? So Q is basically I times T, right? So here I versus time graph is given. I versus time graph is given. That means what we can say is I times T is the charge. If you remember VT graph, V times T is the displacement, right? So if we are able to find the area under the graph, then we will be able to find the displacement. Similarly, in this case, if I and T are given, and we know that the relationship of the charge flowing in the conductor is given by Q is equal to I into T, then the total charge that flows is the area under the graph. Area under the graph. Now, how we can calculate the area under the graph? There are, in this case, you can use different methods. First, you can calculate the area of this triangle, then you can calculate the area of this rectangle and this rectangle and add them. Okay. But what I am going to do, I am not going to calculate 3 times, that will be very difficult for me. So what I will do, I will calculate in 2 steps. First, I will calculate the area of this. This is the trapezium, right? Knowing the formula of area for trapezium is very handy. So this I will calculate first, then I will calculate the area of this one. Okay. So if I add these 2 areas, then I will get this area and that area. If I add them, I will get the total charge. Now the question is about not total charge, it is about the electrons. So we will come to that as well. So first calculate the area. So what is the area of this trapezium? Trapezium's area is sum of the parallel side times difference between the 2 half of that. So the area, say this is, say 1, number 1. Let's say this is number 1. So for area of the trapezium, number 1 is given by half of sum of the parallel times the distance. So distance is 10 seconds, right? Distance is 10. Okay. Now what is the sum of this and this? So this one is, obviously you can tell from the graph, this is 400, this is 200, there is only one line between them. So this graph, this one is 200, this one is 0, so this will be, must be 100, and this one should be 300, right? So this one is 100, this one is 200. So from 0 to 100, this is 100, and from 0 to 300, this is 300. So this plus this is 100 plus 300, that is 400. So this is 400, okay, times 10 seconds, and the unit is milliampere. So it will be given in millicoulomb. Millicoulomb. Right? So the unit will come and mini coulomb, because milli is given here. Now, so it will be 200 times 10, 200 times 10, that is 2000, okay, milli coulomb. Or we know milli is 10 to the power minus 3, so we can remove this, this will come 2 coulomb. Okay, so area of this is 2 coulomb. Now let's find the area of this. This one is 10 to 25, that is the difference is 15. So area of rectangle 2 is given by 15 times, what is the difference? 0 to 300, right? So it will be 4500 millicoulomb or 4.5 coulomb. So total charge is given by, so what is the total charge? Total charge Q is given by 2 plus 4.5. So this is 2, this is 2 coulomb, this is 4.5 coulomb. If you add them, you will get 6.5 coulomb. Now this is the charge, right? This is a long question. This is a little longer question, mathematically, conceptually not so difficult, but mathematically little longer, because you have to do one more step after this. You can find the total charge in multiple ways. First of all, you can calculate this area, okay, then you can calculate this rectangle, and then you can calculate this rectangle, okay, or you can calculate this triangle, this rectangle, and this rectangle. Whichever way you are comfortable, you can do that, but I will use in a two-part strategy. How we can do that in two-part strategy? First, I will calculate the area of this trapezium, and then I will calculate the area of this trapezium, this rectangle. Okay, say this trapezium is rectangle 1, this trapezium is rectangle 2. Okay. Now, first we will calculate the area of this. What is the area of this? What is the area of a trapezium? Trapezium's area is half times. First of all, one more thing I have to do it. What is the value of this? This is 0, right? If nothing is mentioned, this is 0. This is 0, this is 200. So this is in between. So that means it will be half of that, that is 100. Now this is 200, this is 400. So what is the midpoint? Midpoint should be 300. Okay. These things you have to understand from the graph. Okay. If you have understood this, then you will be able to solve this. Now what is the area of a trapezium? Trapezium's area is half times the sum of the parallel sides. Sum of the parallel sides. So this side is 100. Sorry. This side is 100 plus this side is 300, right? Times the distance between them. Distance between them is 10, right? So half times 400 times 10, right? So it will be 200. So it will be 2000. 2000. Now what is the unit? So we have multiplied milliampere times second. Ampere times second is coulomb. Milliampere times second is millicoulomb, right? So here it will be 2000 millicoulomb. Now milli to normal is 10 to the power of minus 3. So milli means 10 to the power of minus 3, right? So here if we multiply with 10 to the power of minus 3, we will be left with 2 coulomb. Clear? Because 1000 means 10 to the power of 3, milli means 10 to the power of minus 3. So that will be cancelling each other. Okay, this part you have to understand. Now, what is the area of this rectangle? Rectangle number 2. Rectangle number 2 is, area is, this length is 300 and this length is 10. 10 to 20, 10 to 20 is 10, right? So it will be 3000, again millicoulomb, or we can write 3 millicoulomb. Now what is the total charge? Total charge is 2 coulomb plus 3 coulomb, that is 5 coulomb. Now we have calculated only the total charge. This is a little lengthy problem. you have to pay attention to the lengthy problem, because it is not so simple, even though you are able to calculate the total charge, but you may not be able to find the this answer to this question, because answer requires total number of electrons that is flowing, right. The question is free electrons. Okay. Now we know that quantization of charge Q is equal to N into E, right. From the quantization of charge we know that Q is equal to N into A. So where here we have to find the number of electrons that is that has flown in the through the circuit. So what is the value? Q is given as 5 coulomb and E is 1.6 times 10 to the power of minus 19. Okay. So if you calculate that, you will get, this is almost 3 times. So 3, if you consider this as 1.5, okay, if you instead of 1.6, if you consider this as 1.5, then 3 times 1.5 is 4.5, right. But here it is 5. So you know that the answer will be close to 3. Okay, you have reduced it little bit. So and you got 3. That means the answer will be close to 3, and obviously there will be 10 to the power of 19. This one will go up and become positive. So you can guess the answer from this calculation. It is not no rocket science. Okay, so you can easily guess the correct option must be this, right. So 3.125. You don't need to do the entire mathematics. Okay, I have to do the calculation till last decimal. No. If you can guess, okay, guesswork is fine as long as all the options are very distant apart. Generally, they give the options quite distinctable so that you do not falter. So, for example, 6.25 has 10 to the power 18. This is also has 10 to the power 18. Okay, even if they have given another value 3.125 times 10 to the power of 18, then it would have been clear that 10 to the power 18 is not possible. Only possible value is 10 to the power of 19. So we will only see whatever values close to 10 to the power of 19 range. So the only option is 3.125. Okay. Now let's move on to the next problem. The IV graph of a conductor for at two different temperatures, 100 degrees Celsius and 400 degrees Celsius, is shown in the figure. The temperature coefficient of resistance of the conductor is about. So in this year there are a lot of questions came from the temperature coefficient of resistor. Now we know that this is I versus V, right. We know that V is equal to IR, or V by I equals to R, okay, or I by V equals to 1 by R, right. This is I versus V graph, right. So what we have to do, this is Y, right, this is Y axis, this is X axis. Now we know that tan theta is given by Y by X, right. Tan theta is given by Y by A. Y is equal to mx plus c. Here c is 0. So y is equal to mx. M is the slope. Slope is tan theta. So tan theta is y by x. Now in this graph, from this graph, if we can find the tan theta, so y is here I and x is v. So if we can find tan theta, that I by v is equal to 1 by r. So from the first graph, say this one is this one is number 1. Okay, this one is number 2. So this one is number 1. Okay, and this one is number 2. So we can write here that 1 by R1 is equal to tan 45. Okay, this angle is 45, right. So tan 45. So 1 by R1 is equal to 1, or R1 equals to 1, right, 1 ohm. So what is R2 then? 1 by R2 is equal to tan 30 degrees. Tan 30 degree means 1 by root 3, right. Tan 30 is 1 by root 3, tan 60 is root 3. So R2's value is root 3, that is 1.73 approximately, right. So we know these values. So put these values. Now here I will ask you to remember one formula. Okay, you can derive that formula on your own, how it is coming, and explain it to me. But if you remember this formula, it will be very handy while solving questions, lengthy question, little bit longer questions quickly. What is that formula? That temperature coefficient is given by the big resistance minus the small resistance. Okay, big resistance here is R2, as you can see 1.73, the small resistance is R1. So R1 is 1 ohm, R2 is 1.73 ohm, right? So big resistance minus small resistance divided by the small resistance times the temperature difference. Okay, this is the formula that you have to remember to calculate the temperature coefficient in one line. Okay, so what is R2? R2 is 1.73, R1 is 1 by R1 is again 1, and what is delta T? 100 degree to 400 degree, right? So 100 degree to 400 degree means delta T is 400 minus 100, that is 300, right? So it will be 0.73 divided by 300. Now if you calculate this, let me simplify this so that you can easily calculate this. So I have taken these two zeros and 1 point from 1 decimal from here, and I have made it 10 to the power of minus 3. Okay, now if you calculate this, this will be 3 to the 6. Okay, 3 to the 6. Then after 2, 1 is left. 3 4 the, there will be decimal, 3 4 the 12, so on. So the answer will be 2.4 times 10 to the power of 3 ohm per degree Celsius. This will be the answer. Okay. Now if you see in the options, none of the options is actually directly matching with the calculated values. So how you can calculate that? How you can guess what is the correct answer? Correct answer is this, because this is the closest answer. Sometimes if the answer is not matching exactly, whatever is the closest value, that you have to mark as the correct answer. Okay, even if you are saying, okay, so the answer is not exactly matching, what should I do? Then this must be a bonus question. No, not always. In some cases, maybe if the variation is very high, in that case maybe they will mark it as bonus. Otherwise you have to choose the lesser evil. Okay, so if there are all of them are evil, then you have to choose the lesser evil, right? So here this is the lesser evil, so you have to choose this as your correct answer. Okay, the electric bulb of 60 watt 120 volt is to be connected to 220 volt source. What resistance should be connected in series with the bulb so that the bulb glows properly? So first step is given, the power of the bulb is given 60 watt, okay, and the voltage rating of the bulb is given 120 volts. Okay, now it is to be connected with a source of 220 volt. Source voltage is 220 volt. Now what is the resistance that you have to connect to it so that the power rating remains the same? Power rating of the bulb remains the same. Now this is a very tricky question, though mathematically not so difficult, but it's very tricky question. What is the trick? Is that first of all you need to know that when you are connecting a bulb in a circuit, okay, the current in the circuit should be the same as only the bulb is connected. Okay, that is one condition, and the voltage drop across the bulb should be the voltage marked in the bulb. That is the second correction. Second point, if these two things match, then you can you can say that the bulb is glowing properly. These are the two conditions that after that you can say the bulb is glowing properly. Now let's see what is the current. We know that power is given by V times I. Okay, power is given by V times I. Now we know that power is given by V times I times t. Now if we take time is 1 second, time as 1 second, then we can write this as we know that power is given by V times I, right? So we can calculate that I is given by P by V. P is given 60 watt, V is given 120 volts, this will be 0.5, okay, amperes. This is the current in the circuit. So when the circuit is constructed, the current should be 0.5 amperes. Now the voltage drop across the bulb is 120 volt. So remaining voltage of 220 volt should be across the resistor, right? The resistor should have the remaining voltage across it. So that is 100. So 220 minus 120 is 100 volt. So what is the current through that resistor? It is connected in series. That means the current will be same. That is 0.5 ampere. So voltage is 100 volts. So resistance will be V by I. So V is 100, I is 0.5. That is 200 ohms. The correct option is option C. Okay. Now this question, before starting, I must say this question is from your deleted syllabus. This is no longer in your syllabus. So if you want to skip, you can skip. But this type of questions may come in your JEE exam because that is still included in the syllabus. So let's read the question. In the experiment to determine the temperature coefficient, again it is a temperature coefficient question. Temperature coefficient of resistance of a conductor, a coil of wire X is immersed in a liquid. This is heated by an external agent. A meter bridge is set up to use the determine of resistance of the coil X at different temperature. The balance point measured in the temperature T1 0 degree Celsius and T2 100 degree Celsius are 50 centimeter and 60 centimeter. So this length, the balance length is first case 60 centimeter, 50 centimeter at 0 degree Celsius, and at 100 degree Celsius this is 50 centimeter for 0 degree Celsius, and at 100 degree it is 60 centimeter. Okay. If the standard resistance taken out to be S is 4 ohm, this is 4 ohm, then what is the temperature of the coil? Now this is an application of Wheatstone bridge. So this is an application of Wheatstone bridge. So you must know what formula or theory you must know is that this by this equals to this by this. Okay. So X by L equals to S by 100 minus L. This is a meter bridge. That means the entire length is 1 meter. That is the length is 100 centimeter. So if this is L, then this will be 100 minus L, right? This much formula only you needed to calculate the both parts. So first part, say resistance was X1. Resistance was X1 at 0 degree Celsius. Where you get the null point? Null point was received at 50 centimeter, and S is given as 4 ohm, and the other one is 100 minus 50. That is again it will be 50. So 4 by 50. Okay, 50 50 cancels. So X1 is 4 ohm. Okay. Now what is X2? X2 is at 60 degree Celsius, 60 centimeter, 100 degree Celsius. So 4, this was at 0 Celsius, this one is 100 degree Celsius. Okay, 4 by 100 minus 60, that is 4 by 40. Okay, 6, 0 0 cancels, this 4 cancels, so only 1 left. So X2 is equal to 6 ohm. Okay. Now the same formula that we have used in our previous problem, same formula we will use here. Instead of R1 and R2, we will use X1 and X2 as in the problem given, it was given in terms of X. So we know that the temperature coefficient is given by the bigger resistance minus the smaller resistance divided by the smaller resistance times temperature difference. Okay. So X2 is 6 minus 4 by 4 times 100. Okay. So it will be 2 by 4 times 10 to the power of minus 2, or 1 by 2. 1 by 2 means 0.5 times 10 to the power of minus 2. Now let's check the options. Options are given 0.5. So in terms of there is no 10 to the power. So let me convert this. So it will become 0.0. 10 to the power minus 2 is there. So 2 zeros and 1 point is already there. So it will be 0.005. So in the given option, this is the correct option, 0.005. Now, a moving electron produces. Moving electron means moving charge. A moving charge always produce electric field as well as magnetic field. This is from electromagnetic theory. So both electric and magnetic field. Simple question, one-liner question, time saver question. A coil having a 9 turns carrying a current produces a magnetic field B1 at the center. Now the coil is rewounded into 3 turns carrying the same current. Then the magnetic field of the center is. Okay, so first case it was said B1, okay, and it was turned how many times? 9 turns. Total number of turns was 9. Okay. Now say the radius of the coil is R, suppose. Then what is the total length of the wire? Total length of the wire is perimeter. Perimeter is 2 pi R times the number of turns. Number of turns is 9, right? This is the length of the entire wire. Now you open the wire, you rewind it. What thing remains the same? Yes, the length of the wire remains the same. In the second case, suppose when it is wounded only 3 turns, okay, only 3 turns, okay, the radius becomes say capital R. So in that case, L will be same L, 2 pi capital R times number of wound is 3, right? So this is the two lengths that we need to compare. 2 pi small r times 9 equals to 2 pi capital R times 3. Okay, 2 pi cancels. 9 small r is equal to 3 capital R, or capital R equals to 3 small r. Okay, this is the relation that we have received. Now, one thing you need to know, you don't need to do a lot of things. Only thing you need to know is that magnetic field produced by moving current at the center is proportional to the number of turns divided by the radius. Number of turns divided by the radius. There are other formulas, but you don't need to remember all the things. You just need to remember that it is directly proportional to the number of turns and inversely proportional to the radius of the wire. So now let me write it B1 by B2. Okay, let us try and write B1 by B2 in this part. Give me a second to clean up the board. Okay, so what is B1? B1 is N1 divided by small r, and B2 is N2 divided by capital R. All the other parts will be cancelled, so only thing we need to consider is these two. So what is N1? N1 was 9 times, obviously small r. Now N2, what is N2? N2 is 3, number of wounds is 3, and capital R is 3 small r, right? So if you just simplify it, 9 by R times 3R by 3. So this will reverse, 3 cancels, R cancels, so this becomes 9. So B1 by B2 is 9. Now you have to find the B2. So B1 by B2 is 9. So B2 will be, this B2 will go up, this 9 will come down, so B1 by 9. This is the answer. What is correct answer? Correct answer is option A. Okay. Now, a particle of specific charge q by m pi c pi coulomb per kg is projected from the origin towards the positive x-axis with the velocity 10 meter per second in a uniform magnetic field B equals to minus 2 kT. The velocity of the particle after time t is equal to 1 by 12 second will be. So, what is happening? You have projected a particle. Now, in this case, what will happen? The particle will complete a circle. It will complete a circle. It will complete a circle like this. Okay. So, in this case, what is the time period of the motion? You have to have the knowledge that when a particle is projected like this, it is moving in a circular motion, and the time period is given by 2 pi m by q times b. 2 pi m by q times b. This is the time period of the particle moving in a circular motion placed in a magnetic field. Okay, you have to know this formula. Now, for the given charge, q by m is given. Q by m is given as pi. So, q by m is pi. So, what is m by q? 1 by pi. So, if you see here, it is m by q, right? So, we can write this as we can write this as 2 pi times, sorry, divided by pi times 2, right? B is given, magnitude of B is 2. The direction does not matter, direction is only for, since perpendicular, the velocity and the magnetic field is perpendicular, it will move in a circular motion. That is the only thing important. So, pi cancels, 2 cancels. So, 1 second. So, the time period of the motion in this case is 1 second. So, that is mostly important. Now, if time period is 1 second, what is the meaning of that? If the time period is 1 second, that means when the object is rotating in a circular motion, okay, when the object is rotating in a circular motion, then in that case, after 1 second, it will complete one full circle, one full rotation. So, what is the angle that it rotates after one full rotation? This is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi, right? So, total angle rotated in 1 second is 2 pi, because time period is 1 second. So, if time period is 1 second, that means in 1 second it rotates 2 pi angle. So, how much angle it will rotate after 1 by 12th of a second? So, it will rotate say at angle theta. So, that will be in 1 second it rotates an angle 2 pi. Then in 1 by 12th second, how much it will rotate is this, that is pi by 6. So, what is pi by 6 means? Pi by 6 means 30 degrees, right? 30 degrees. Now, at any instant the velocity vector will point in this direction, right? So, velocity vector is pointing in this direction. The angle rotated by it, will be, what will be the angle rotated by it? This angle is 30 degrees. Now, what is the component then? The velocity will be this and this, right? This is cos theta component and this is sine component, right? So, the velocity vector will be v, that is 10. Let me clean it. We remember the angle 30 degrees, that is only important. So, v vector will be this 10 value cos of 30 degrees I cap, right? This is along x axis, plus 10 sine of the angle 30 degrees j cap. Okay. So, cos 30 is root 3 by 2 and sine 30 is half. I cap, j cap, so 2 cancels, 5 root 3 plus I cap, 5 root 3 I cap plus 5 j cap. Okay. So, the correct answer, if you take 5 common, root 3 I cap plus j cap. This is the correct answer. So, correct option is option C. Okay. Now, let us move on. Question number 44. The magnetic field at the center of a circular coil of radius r carrying current is 64 times the magnetic field at a distance x on its axis from the center of the coil. Then the value of x is. So, here it is given magnetic field due to a current carrying loop at the center, say this is BC, and at some point Bx at a distance is given x. So, Bx times 64 is Bc, right. So, what we have to do? We have to find the value of x. Now, for that we have to know the magnetic field given at a point x is given by, is proportional to, basically you can say that is proportional to r square divided by x plus r, sorry, x square plus r square to the power 3 by 2. You don't need to remember what is mu naught I is there. Okay. If any other constant is there, 2 pi is there, 4 pi is there, they will all cancel. So, only the thing you need to remember is what is the variables and how they are related. So, Bx is basically proportional to this value, right. Now, what will happen at the center? Obviously, at the center x is 0. So, you can say because x is 0, it will cancel r square by r to the power square to the power 3 by 2, that is r cube. So, it will be proportional to 1 by r. It is proportional to 1 by r, right. Now, what we have to do? We have to divide it. So, BC by Bx. BC by Bx is 64, right. So, what we have to do? We have to put the values. BC is 1 by r and Bx is r square to the power x square plus r square. So, even though if you have forgot the formula, exact formula, you don't remember the exact formula, you can still solve it as long as you know how the variables are related. You don't need to remember exact formula for each and every thing, but you have to remember at least the structure of it, so that you can apply that law. Now, you have to do this. So, 1 by r times x square plus r square to the power 3 by 2 divided by, so this will come down to r square. So, it will be x square plus r square to the power 3 by 2 divided by r cube is equal to 64. Okay. Now, so now if we take the entire thing inside the this 3 by 2 thing, okay, this is cube, right. So, it will normally become r square, because there is a half here. So, x square plus r square divided by r square equals to 64 means what? 64 means 4 cube, right, 4 cube. Now, or also we can write 4 cube as we can write this as 16 to the power 3 by 2. Why? So, we have divided, we have done a square root of a number, so we have to square it inside, right. This is a trick. So, the thing will become x square plus r square divided by r square equals to 16. So, the 3 by 2 now cancels. So, x square plus r square equals to 16 r square So take it on the other side, so it will become x square is equal to 15 r square, or x equals to square root of 15 r. This is the answer. So correct answer is correct answer is not this one. Correct answer is this one. Okay, this is the correct answer. Now, the magnetic hysteresis is exhibited by dash magnetic materials. Now, hysteresis is deleted, so this is a deleted question. Correct answer is only ferro, but it is a very simple trivial question. If you have know the concept, you can answer it, and a time saving question. Magnetic susceptibility of Mg at 300 Kelvin is 1.2 into 10 to the minus 5. What is its susceptibility at 200 K? This is also a deleted question. You need to know that susceptibility depends on 1 by temperature, okay, 1 by T. So here susceptibility at it is in terms of absolute temperature, 1 by absolute temperature, okay, proportional to absolute temperature. So xi 1 by xi 2 is equals to T2 by T1. Okay, xi 1 is given at 300, xi 1 is given 1.2 times 10 to the power of minus 5, right? And xi 2 we are trying to find. So xi 2 we leave it as xi 2. T2 is given as 200 K. T1 is given as 300 K. Okay, so xi 2 will be, this one will go up, cross multiplication, 3 by 2 times 1.2 times 10 to the power of minus 5. So this will become 0.6, that is 1.8 times 10 to the power of minus 5. So 1.8 times 10 to the power of minus 5. Now, this is a very interesting question. Okay. Now, this is a bonus question. Okay, I will explain why it is a bonus question. It was given bonus. A uniform magnetic field of strength B equals to 2 millitesla exits vertically downwards. This magnetic field lines passes through a closed surface as shown in the figure. The closed surface consists of a hemisphere S1, a right circular cone S2, and a circular surface S3. The magnetic flux through S1 and S2 are respectively. So, if you see, magnetic field is entering along a hemispherical surface and it is exiting along a conical surface. What is the thing? They have in between, they have a common circular surface. Okay. So, they have a common circular surface here. Now, if you cannot calculate the flux exactly, because you have to take the magnetic flux each case and find the angle if you try to calculate it not regularly. But you know that if you consider this circle, and you know that at each and every point it is entering perpendicularly, okay, and it is exiting perpendicularly, and whatever flux is entering, the same flux has to exit it. There is no net magnetic monopole inside the inside this, and we know that from magnetic monopole does not exist. So, flux through the closed surface is always 0. That is the Gauss's law of magnetism. But what we know that whatever flux enters, the same amount of flux should exist. So, whatever flux is entering through this hemisphere, they has to pass through this right circular surface S3, and through the same surface it will exit. So, we can calculate the entering through the S1 and exiting through S2 by simply calculating the flux passing through S3. Okay, this one S1 will be positive, S2 will be negative. That's it. Now, the problem with this problem is they have given the unit of the question. In the answer also units are given, but there is no unit given for this R. Okay, if the R has no unit, then these units are meaningless. That's why this question is incomplete. So here we will take this unit as centimeter and we will solve this problem. So how we can solve this? Flask is basically B times A. Okay, magnetic flask through a surface is given by magnetic field times the area. Now what is the area of this? The area of this is pi r square, right? Area is pi r square. B is given to millitesla, 2 times 10 to the power of minus 3, and the area is pi r square. Pi times r is 10 to the power of 10 divided by pi root pi times, this is in centimeter, it will be minus 2 whole square, but centimeter was not given, so it was not coming as micro Weber. Okay, if you take it as 1 meter, then this or in terms of meter is the more common unit, so that's why you are not able to solve it without the unit. Okay, so that's why it was a bonus question. Pi times 100 divided by pi times 10 to the power of minus 4. Okay, so this pi cancels, you will get 200. So the phi, just a second, phi is given by 20, 2 into 100, 200, 10 to the power of minus 7, but answers are given in terms of micro. Micro means 10 to the power of minus 6. So what we will do? We will reduce 1 0 and write it as 20, and then we will calculate this as 10 to the power of minus 6 Weber. Okay, Weber is the unit of magnetic flux. So it will be 20 micro Weber. Okay, so 20 micro Weber, that is entering through this, so this is plus, and exiting through this, that is minus. So correct answer is all the options. Actually this will be plus, this one will be minus. Okay, correct answer will be option A. Okay, now 48, in the figure a conducting ring of surface certain resistance is falling towards the current carrying state long conductor. The ring and the conductor are in the same plane. Then okay, so current is flowing through this. Now it is a very conceptual question. You don't need to do any mathematics, but you have to apply the concepts. So if a wire is carrying current, say in this direction, what is the direction of magnetic field around it? So magnetic field around a straight current carrying conductor is in circular in nature, and its direction is, if you point your thumb towards the direction of current, then if you curl your hand like this, whatever your finger points towards, that is the direction of magnetic field. So if the current is in this direction, then the magnetic field is in this direction, right? So this is the thing you need to remember. This is the trick that you need to remember. If this is the current, this is the direction of magnetic field. So in this case current is flowing in this direction, so the magnetic field will be, you have to first align your thumb in the direction of current, then whatever your point towards, finger point towards, that is the direction of the magnetic field. So magnetic field around this coil is out of the surface. Magnetic field around this coil is out of the surface, right? And as you know that magnetic field is strong closer to the wire and it is weaker as you move away. So basically this coil is passing through a time varying magnetic field. That's why what will happen, this will induce a current into this. Now what will be the direction of that induced current? The induced current should oppose this magnetic field, right? Now we know that for a circular coil, okay, the magnetic field, if the current is flowing, say suppose in this direction, the magnetic field in this will be pointing outward, and if the current is flowing in this direction, then the magnetic field will be inward, right? Any doubt? So in this case, the magnetic field produced in this coil should be inward direction, right? Because the original magnetic field is outward direction and it is increasing. That's why we can say the magnetic field induced in the coil should be opposite to that, that is, it is opposing to the magnetic field. So opposing to the magnetic field means it will be inward. Inward means in this direction. And what is this direction is? This direction is clockwise. So this is a clockwise. So induced current will be clockwise. That is option C. Okay. Now, an induced current of 2 ampere flows through a coil. The resistance of the coil is 10 ohms. What is the change in the magnetic flux associated with the coil in 1 millisecond? The induced current. So induced current is 2 ampere. Okay, and resistance is given 10 ohm. Now we know that what is the induced EMF? Induced EMF is given by I into R, obviously, right? Induced EMF is responsible for the current for flow of the current. So induced EMF will be I into R. I is 2, R is 10, that is 20, okay, volt. That is the induced current. Now again, from Faraday's law, we know that the magnitude is given by d phi by dt. That is rate of change of magnetic flux linked with the coil, right? So, so magnetic flux linked with the coil is d phi by dt. That is equals to 20 volts. Now, what you have to do is the magnetic flux change in the magnetic flux. Change in the magnetic flux means only d phi you have to calculate. That is 20 times dt. Okay, 20, and dt is given 1 millisecond. 1 millisecond means 10 to the power of minus 3 Weber. Okay, so it will be 2 times 10 to the power of minus 3, or if you arrange it, it will become 2 times 10 to the power of minus 2 Weber. You have to be careful, don't fall in the traps of this or this or this. The correct option is option B, 2 times 10 to the power of minus 2. Now, okay, a square loop of side length A is moving away from the infinitely long current carrying conductor at a distance at a constant speed v as shown in the figure. Let x be the instantaneous distance between the long conductor and the side AB. The mutual inductance m of the square loop of the long conductor pair changes with time t according to which of the following graphs. So this is also a very complicated question if you try to understand each and every theory, but if you are smart and if you only using the relation basic relations, it is very easy. So first you have to understand that the magnetic field, what is the magnetic field? Due to a current carrying conductor at some distance, say x from the wire. So magnetic field is basically proportional to 1 by x. Magnetic field is proportional to 1 by x. Now it is moving with the velocity v. It is moving with the velocity v. Okay. So after a time, some time t, say after some time t, what will be the distance? Distance is s is equal to vt. Here x will be equals to vt. So we know that magnetic field then must be proportional to, inversely proportional to time t. V is constant, so we are not taking v here. So we are only taking time t. So B, magnetic field B is proportional to inversely proportional to the time t. Now mutual inductance is proportional to the flux linked with the coil. Here is a rectangle, so the flux is linked with with this coil. So that is proportional to the flux linked. Now flux linked is B into area. Flux at any point is B into area. Now area is constant. Area is constant means mutual inductance is directly proportional to the magnetic field. So mutual inductance is directly proportional to 1 by time. Okay. So mutual inductance will decrease with time. Mutual inductance will decrease with time. That means inversely decrease, that means the correct option is only this. Okay, even it is decreasing linearly. It is not decreasing linearly. Okay, it will be a rectangular hyperbola. So whenever one variable is proportional to 1 by t, then it can be considered as rectangular hyperbola. The only hyperbola, that is this. Okay. Which of the following combinations should be selected for better tuning of an LCR circuit used for communication? Now this is also an out of syllabus question. Quality factor is no longer in your syllabus, so this is also an out of question. Now quality factor of a circuit is given by 1 by R, okay, square root of L by C. Okay, this is the basic relation of a quality factor. Now you have to check for low value of R, high value of L, low value of C. So what are all the combination in the given values? The lowest possible R is 15 ohm. Okay, lowest possible value is 15 ohm. Highest value of L is 3.5. Okay, and the lowest value of C is 30. So the correct option is option D. Okay, so you have to see which for a high value of quality factor. High value of quality factor means all the divisions are lowest and all the things that is a numerator that should be highest. So only option from the given option is option D. That data was deleted. Okay. Now in an LCR series circuit, the value of only capacitance C is varied. The resulting variation of resonance frequency F naught as a function of C can be represented as. Now here many students complain this is also out of syllabus. This is not out of syllabus because resonance frequency is still included in your syllabus, and resonant frequency is given by 1 by 2 pi, 2 pi by square root of LC. 2 pi by omega. Omega is square root of LC, so F naught is 2 pi by square root of LC. Now here L is constant, only thing that is varies is capacitance 1 by root C. So resonance frequency is again decreasing with capacitance C. The correct option is this. Okay, this is the only possible option, right? This is not the correct option. Many students has corrected this. This is not the correct answer because resonance frequency is decreasing as you increasing the capacitance. Okay, so resonance frequency is decreasing as you are increasing the capacitance. Now, this is also a very important question from alternating current. The figure shows a variation of R, XL and XC with the frequency F in a series LCR circuit. For what frequency point in the circuit the circuit is capacitive? So for a capacitive circuit, remember that the circuit is capacitive only when XC is greater than XL. Does not have anything to do with R. Circuit is capacitive when XC is greater than XL. Circuit is inductive when XL is greater than XC. Okay, and circuit is in resonance when XC is equals to XL. This is the condition of resonance. This is inductive. This is capacitive. So where now look into the graph and tell me where the XC is greater than XL. So XC is this one. So it was started at a high value. Slowly it is decreasing. Slowly it is decreasing. Okay, and XL started at a low value and it slowly started increasing. Right. So at this point they intersect each other. That means at this point they are at resonance. They have equal value, and XL increased from this point on and XC decreased from this point on. So whatever points on left hand side of this point, that is capacitive. That means from the given option, point A is capacitive, right? So point A is capacitive. Option is correct. Option is option C. Electromagnetic waves are incident normally on a perfectly reflecting surface having surface area A. I is intensity of the incident electromagnetic radiation, and C is the speed of light in vacuum. The force exerted by the electromagnetic wave on the reflecting surface. This is also deleted in the from the syllabus. The correct answer is this. Okay, 2IA by C. You have to remember this formula. You had to remember this formula, but now this part is deleted from the syllabus. The final image formed by an astronomical telescope. So astronomical telescope is what we watch using our eye. So that means it has to be virtual. Okay, and a telescope always forms an image which is magnified. That means virtual and magnified combination you have to look for. Virtual and diminished, virtual and magnified. So only correct option is option D. Inverted is a bonus. You don't need to consider bonus. You can consider, but if you are at least collecting two correct information, then it will be correct, because you are not seeing using an old astronomical telescope like Galileo used to watch. It was pointed towards the stars and he watched it through the eyepiece. It is not formed on a screen. If it is forming on a screen, that means it's real, but if you are watching using your eyes, that means the final image has to be virtual. Okay. If the angle of minimum deviation equal to the angle of prism for an equilateral prism, then the speed of light in the medium in the prism is. So we know that mu is sine A plus angle of deviation by 2 divided by sine of A by 2, right. This is the formula that we have learned for angle of deviation. Now here it is said that the prism is an equilateral prism. Equilateral prism means all the angles are 60 degrees, right. Also it is mentioned that A is actually equals to dm, right. Just put that in this equation, you will get sine A plus A by 2 divided by sine A by 2, right. So you can write here mu as sine A by sine A by 2. Now you can simplify this using trigonometry and write it as cos A by 2, or you can put the value of sine 60 by sine 30, that is also fine, because sine A by 2 means 30, right. Or what you can do, little fancy way is sine A by 2 cos A by 2. This is a little fancier way, okay, by sine A by 2. But in this problem it does not matter. Okay, if it is just a theory question, you have to know this part. Okay, sine theta is equals to sine 2 theta is equals to sine 2 sine theta cos theta. So here instead of sine 2 theta, we have written sine 2 A by 2. Okay, so then we have simplified. This is the value. What is the value? Angle was 60 degree. So A by 2 is 30. So cos 30 means root 3 by 2. 2 cancels. That is root 3. Okay, so root 3 is the mu, right, refractive index. Now mu is, what is mu? Mu of a medium is given by speed of light in a medium divided by speed of light in that medium, that is equals to root 3, right. So in this case, speed of light in that medium divided by speed of light in vacuum divided by speed of light in medium is mu. So V will be C by root 3. Now C is 3 times 10 to the power of 8 divided by root 3, cancels root 3. So it will be root 3 times 10 to the power of 8 meter per second. So the correct answer is this. Next, this is a very interesting question. Here it is given a luminous point object placed at a distance 2r from the spherical boundary separating two transparent media of refractive indexes n1 and n2 are as shown, where r is the radius of curvature of the spherical surface. If n1 is equals to 4 by 3 and n2 is equals to 3 by 2 and r is equal to 10 centimeter, the image obtained at the distance from P is equals to, so we have to calculate it using a formula. We know that mu 1 by u, formula we know that mu 2 by V minus mu 1 by u equals to mu 2 minus mu 1 divided by r. Okay. When for spherical surfaces, if you remember, we have done this derivation. So for spherical surface, the if this is n1, this is n2, instead of n1 mu1 and mu2, we can write this as n2 and n1. Okay, we can write this as in terms of n, because n is given. So n2, n1, n2, n1. Okay, so we have to calculate. U is given 2r. Okay, U is given 2r. So n2 is given 3 by 2. So 3 by 2 by V equals to eraser, it will be minus 4 by 3 times 2r equals to 3 by 2 minus 4 by 3 by r. Okay, so let's take this on the other side. 3 by 2v equals to, just simplify this, this will become plus, and it will become 4 by 6r, right? 4 will be in the top, 6 will come down, it will become one more thing here, u is negative. Why u is negative? Any object located left hand side of the any surface, mirror or anything, that is considered negative. Anything is on the other side is considered positive. So if the object is located in this side, because this is the object, right? So object is located on the left hand side of the surface. That means this distance, this u is always negative. We remember the sign convention. In the sign convention, anything on the left hand side is considered negative. So this will be negative. So negative, negative, positive. So when it comes to other side, it will become negative. Now let's solve this. What is 3 by 2 minus 4 by 3? 3 by 2 minus 4 by 3 is 3 2s are 6, right? 3 3s are 9 minus 2 4s are 8. So this is 1 by 6. Okay. So this 6 will come down and it will become 1 by 6r. Right. So this is minus 4 by 6r plus 1 by 6r. So you can simplify this simply by just subtracting that, you will get minus 3 by 6r. Okay. So you can calculate 3 by 2v equals to minus 3 by 6r. Now cross multiply, it will come out 3 times 6r divided by 2 times 3. The negative sign also we are transferring, equals to v. So only v we have taken on the other side, everything else come to the left hand side. Or we can write this as v equals to 3 cancels, this cancels, 3, so minus 3r. Okay, this is the answer. So minus means it will be again on the left hand side. Now r is given as 10 centimeter. R is given as 10 centimeter. So it will be on the left hand side because the final answer is negative. Final answer negative means image will also form on the left hand side. So 30 centimeter in the rarer medium, right? This is rarer, this is rarer, this is denser. So it is 1.3 approximately, this is 1.5 approximately. So 30 centimeter in the rarer medium. An equiconvex lens, this is also another interesting question from ray optics. An equiconvex lens of radius of curvature 14 centimeter is made up of two different materials. Okay, left half and right half of the vertical portion is made up of material of refractive index 1.5 and 1.2. So this is 1.5, this is 1.2, as shown in the figure. If the equiconvex lens means both sides has the same radius of curvature. This side has radius say r, then this will also have r. Okay, radius of curvature. If a point object is placed at a distance of 40 centimeter, calculate the image distance. Okay, radius of curvature is given 14 centimeter. This is also little bit longer question, not difficult but longer question. First of all, we have to use lens maker formula to calculate focal length of each side. So, suppose this side is f1, this side is f2, then from lens maker formula it will be mu minus 1 times 1 by r. Other r will be either it will be 1 by infinity or it will be minus 1 by infinity. So, it will be cancelled, and in both cases you will find only this. Okay. So, for mu 1 1.5 minus 1 times 1 by r, or 0.5 divided by r is 14. So, it will become 1 by 28, right. We are not finding f1 by reversing it, eventually it will be very helpful for us. Similarly, 1 by f2 will be, what will be the 1 by f2? 1.2 minus 1 divided by 14, that is 0.2 divided by 14. Now, if you simplify this, this will come 1 by 5570. Okay. You just need to multiply both sides with 5, then it will become 1, this will become 70. So, now these two lenses are in contact. So, what is the equivalent focal length of two lenses in contact? Two lenses in contact, the equivalent focal length is given by, remember these two values, 1 by 70, 1 by 28. So, we know that two lenses in contact, equivalent focal length is given by 1 by f is equal to 1 by f1 plus 1 by f2, like resistances in parallel. So, 1 by 28 plus 1 by 70. Simplify this. Okay. 140, this will be 5, this will be 2 obviously, then it will be 7 by 140, 1 by 20. So, the 1 by f will be 20. So, now you have to calculate the V. Now, if you remember that the point is placed at a distance 40 centimeter. The distance 40 centimeter means what? For a lens, distance is 40 centimeter. 40 centimeter is focal length. What is the focal length? Final focal length is 20 centimeter, right? So, the object is placed at which point? Object is placed at 2f. So, object is placed at 2f, that is 40 centimeter. If the object is placed at 2f, what is the image? Where is the image formed? Image is formed also on 2f on the other side. So, basically the image distance will be 40 centimeter, right. So, this is where you save time. If you have calculated this much and you have deduced that f is 20 centimeter, 20 centimeter means 2f is 40 centimeter. If 2f is 40 centimeter, that means final image will also be at 40 centimeter on the other side. A galaxy is moving away from the earth, so that the spectral line of 600 nanometer is observed at 601 nanometer, then the speed of the galaxy with respect to the earth is. Now, this is also a deleted question, deleted portion from the syllabus, but let us solve it. Speed of galaxy divided by speed of light is given by delta lambda divided by lambda. Okay. Speed of galaxy divided by speed of light is delta lambda by lambda. Here delta lambda is 601 minus 600 divided by 600, okay, or V equals to C, that is 3 into 10 to the power of 8 meter per second divided by, this is 1 times 1 divided by 600. Okay. So, this will comes out 200. So, 1 divided by 200. Now, if you simplify this, it will come, we are having the answer in terms of kilometer per second, right. So, kilometer means 10 to the power of 3. So, we will get 10 to the power of 5 divided by 200 kilometer per second. Here it is meter per second, right. Now, 10 to the power 5 means, you just simplify it, make it 1000 times 100, that will be easy, kilometer per second, right. 10 to the power 5. So, 200, we have calculated this, 0, 0, 0, 0 cancels, this 2, becomes 500. So it is 500 kilometer per second. Now this is Doppler effect that is deleted, so this question is deleted. Next is, this is very interesting question. The polarization, the three Polaroid sheets are coaxially placed as indicated in the diagram. Pass axis of the polarization 2 and 3 makes 30 degree and 90 degree with pass axis Polaroid sheet 1. If I naught is the intensity of incident unpolarized light entering sheet 1, the intensity of the emergent light through sheet 3 is. Very, very interesting question. So when I naught light enters in a Polaroid, okay, when I naught light enters in unpolarized light enter a Polaroid, its intensity becomes I naught by 2 after passing through the Polaroid. So when unpolarized light of intensity I naught passing through a first Polaroid, its intensity becomes I naught by 2. Okay, so intensity becomes I naught by 2. From next time onwards, the angle between the next Polaroid is what important. So I equals to, for this one say I2. So this one say I2, this one say I3, this one say I1. So I1 is just half of the incident radiation. Always I1 is half of the incident radiation. Now I2 is I1 cos square theta, that is Malus law. Okay, so I1 is I by 2, I naught by 2. What is theta? Theta is, the angle is 30 degree. First angle is 30 degree. So the angle is 30 degree, that means cos square 30 degree. Cos square 30 degree means root 3 by 2 whole square, that is I naught by 2 times 3 by 4. Okay. Now from here to here the angle is, total angle is 90 degree. That means what is the angle difference here? Angle difference here is 60 degree. Okay. Do not fall for the trap that okay, angle is 90 degree, that means intensity will be 0. No, intensity won't be 0. So I3 will be I2 cos square 60 degrees. Why 60 degrees? Because the angle between two consecutive Polaroid is important. What is the angle between first and last does not matter. Only the angle between two consecutive Polaroid is important. Here it is 60 degrees. So it will be, so here it was 3 I naught by 8. Okay, so put the value 3 I naught by 8 times 1 by 2 whole square. That is 3 I naught by 8 times 4. So it will be 3 I naught times 32. So 3 I naught times 32, the option is correct option is B. Okay. So if you have any doubt, don't forget to mention that in the comment, and if you have liked our video, don't forget to subscribe to our channel. If you think it is helping you, don't forget to share with your friends, and I thank you for watching this video.